Hi students, in this video we will understand what is the equation of coordinate axis and equation of horizontal line and vertical lines. So to begin with, we will understand the equation of coordinate axis. Let us consider coordinate system and first we will understand the equation of x-axis. Y coordinate of every point on x-axis is 0. You consider any point on x-axis. How will the coordinates look like? It is like 0, 0, 1, 0, 2, 0, 3, 0, 4, 0. What is happening? Coordinates of x is changing. Y coordinate is 0 only because it is on x-axis, right? So here if you come to the left side of y-axis, it is minus 1, 0, minus 2, 0, minus 3, 0, minus 4, 0 and so on. So any point on x-axis you consider, the y coordinate will always be 0. So for all the points on x-axis, y coordinate is 0. So isn't this a common property for all the points on x-axis? Yes, that is all the points on x-axis satisfy a common property, which is y is equal to 0. We are using that common property and calling the equation of x-axis as y is equal to 0. You check any point in the coordinate system except for points on x-axis, no other point will have y coordinate 0. The moment y coordinate is 0, it is clear and evident that the point is on x-axis. So except for this line, on no other point in the whole coordinate system, y will be 0. So the moment you see y is 0, the point lies on x-axis. So this is the equation of x-axis. Now equation of y-axis, and the logic is same. You consider any point on y-axis. What is x-coordinate? X-coordinate is 0 because on y-axis x-coordinate is 0. Only y will be changing. You consider this point, it is 0, 0. This is 0, 1, 0, 2, 0, 3, 0, 4. What is happening? Y coordinate is changing. The height is increasing, but x coordinate is 0 only. Now down below 0, minus 1. This is 0, minus 2, 0, minus 3, 0, minus 4 and so on. So only y coordinate is changing. X remains 0 only on y axis. So this is the common property. On y axis, all the points will have x coordinate as 0. This common property is what we are using to find the equation of y-axis. That is, nowhere in coordinate system x will be 0 except on y-axis. So this is the condition. Thus equation of y-axis is 0. Hope this is clear now. Equation of lines parallel to coordinate axis is what we are learning in this video now. So first we will learn equation of lines parallel to x-axis. Consider the coordinate system. I am considering a line which is parallel to x-axis and it is at a distance of a units from x-axis. Clear? Maybe this a can be 2, 3, 5. It can be anything. So you consider any point on this line which is parallel to x-axis and it is at a distance of a units from x-axis. Then what is this a units? It is y coordinate, right? It is the height. That means x coordinate changes and y coordinate remains the same throughout for any point on this line. That is, you check this point, it is x will be 0, y coordinate will be a. This is 1, a, 2, a, 3, a, 4, a and so on. Here minus 1, a, minus 2, a, minus 3, a, minus 4, a and so on. That means what is the common property here? Y coordinate is a. That is the common property. Wherever you check on this line, whatever point you consider on this line, y coordinate is a itself. It is not changing. So this is the property we are using to find the equation of the line parallel to x-axis. Thus equation of the line parallel to x-axis and is above x-axis. That means this is at a distance of a units and the height is a positive quantity here. So the equation of the line is y is equal to a. So if this a happens to be 2, that means this line is at a distance of 2 units from x-axis, then y is equal to 2. It can be at a distance of 5 units from x-axis, then it is y is equal to 5. The equation of the line goes like this. Suppose there is a line which is parallel to x-axis but below x-axis and at a distance of same a units. It is below x-axis. So you consider any point on this line. Again, y coordinate will remain same. Only x coordinate will change. What will happen? This is 0 comma minus a because this is at a distance of a units from x-axis below x-axis, right? That is why the coordinate will be minus a. So this is 0 comma minus a. You move ahead. This is 1 comma minus a, 2 comma minus a, 3 comma minus a, 4 comma minus a, 5 comma minus a. Again here minus 1 comma minus a, minus 2 comma minus a, minus 3 comma minus a, minus 4 comma minus a. What is changing here? Only x coordinate is changing. Y coordinate is a constant here. That is the distance, which is this a units. Because it is below x axis, it is minus a. The y coordinate happens to be minus a. So the equation of the line parallel to x axis, and if it is below x axis, then the equation of the line would be y is equal to minus a. For example, y is equal to minus 3, y is equal to minus 10, and so on. So hope this is clear now. Now equation of lines parallel to coordinate axis. Now we are considering equation of the line parallel to x axis. So consider a rectangular coordinate system. Now we are considering a vertical line or a line parallel to y axis, which is at a distance of a units from y axis. So if it is at a units from y axis, what is this distance? Then it is x, right? Yes. Now this distance is fixed. You consider any point. Is this distance changing? No, it doesn't, because this is a line parallel to y axis. This distance doesn't change, correct? So what is fixed here? X coordinate is fixed. Y is only changing. Now look at this. This is a comma 0, a comma 1, a comma 2, a comma 3, a comma 4. X is fixed, y is changing. Here it is a comma minus 1, a comma minus 2, a comma minus 3, and so on. So what is fixed? X is fixed. Any point on the line, the x coordinate is always a and only y coordinate is changing. So it's like this. Now consider a line parallel to y axis, which is again at a distance of a units but to the left side of y axis. So this is minus a comma h. Correct? It is at a distance of a units but to the negative side of x axis. So x coordinate will be minus a. Here again, you consider any point on this line, x coordinate will be equal to minus a. Only y coordinate will be changing. So this is minus a comma 1, minus a comma 2, minus a comma 3, minus a comma 4, minus a comma 5. Here down below, minus a comma minus 1, minus a comma minus 2, minus a comma minus 3, and so on. So again, this as a common property, we will find the equations. So equation of a line parallel to y-axis and is to the right of y-axis, that means this. Then equation is x equal to a. That is the common property for all the points on this line. So for example, if this is at a distance of 2 units or if it is at a distance of 5 units, what will the equation be? It is x equal to 2 or x equal to 5, like that. This equation of line parallel to y-axis and is left of y-axis is x equal to minus a. So it is at a distance of a units but to the negative side of x-axis. That is why it is x equal to minus a. So it can be x equal to minus 3, x equal to minus 10 depending on the distance from y-axis. These are the equations of line parallel to y-axis.